The challenge session for water power is carried out in room EL-130, coming in from the northeast corner of the engineering lab building. You're going to find classroom number 130, the hydraulics lab. Inside the hydraulics lab, there's going to be a sign that says water engineering, water power, and right behind it is our classroom, which is basically the hydraulics lab. There are 6 tables. The first 5 tables have 4 chairs, and the very last one has 5, so we can accommodate a total of 25 students for the experiment. In each table, there will be the following equipment: a pair of gloves, a ruler, a protractor, a compass, pair of scissors, pliers, and a pen. The pen is actually not a necessary equipment, but it does have the civil engineering sign in there. And then there is a piece of sheet metal with a hole in the middle. That's what the students are going to build their water wheel. The water wheel should look somehow like these models right here. It's all that is cut out of one of these sheet metals. Each table gets one piece of sheet metal, and they make the water wheel out of that. And in this box, which I'm going to put under the table, right there's additional pieces of sheet metal. And we're going to leave this out here as examples of the things that can be done, right? And then the students are going to build the water wheel. We're going to test it in this equipment, and I'm going to show you in a different video how to do it. And then the data is going to be entered into this computer. Now, to turn on this computer, this is a very old computer, so you're going to have to do the following. Right at the top, there's this button. Just pull it to the left for a second, and as soon as that turns green, then the computer is turning on. But because it's an old computer, it's going to take a while to turn on, so I'm just going to let it go for a while. As you can see, it's a Windows XP computer, vintage, somewhere in the year 2004, sometime 2000. So let's going to go back to the table here and see what the students are going to be doing. The gloves is for whoever's going to be cutting the sheet metal. The ruler will be used first. Each student is going to come here and measure the diameter that they're going to be given to the wheel. The chamber where the wheel is stuck can be opened. Very carefully, just release this a little bit and then pull out this cover, and then the diameter of the chamber is the maximum length of the maximum diameter of the wheel they can use, but they gotta use it a little bit smaller so that there is no heat in the walls of the chamber. Now, in order to install the water wheel, there's a button back here, looks like a screw, that you're gonna hold down. When you hold that down, then you can take this nut out. Then you're gonna put this in there, in between these 2 bushels, and then tighten it up. I'm gonna show you more detail that. And then in order to run the train, we're gonna close the chamber right here. And tighten this. But we're gonna do that later on. I was gonna say the computer is turning on. There's a mouse here, and where you're just gonna go to the administrator, to this administrator icon, and click it on, which will start loading the computer's operating system, and I'm going to go back to that. So what the students are going to be doing is measuring first. I forgot to bring my ruler back. Measuring the diameter. That's going to give them an idea of how much they're going to have to build their water wheel. Then with a compass they can trace the outskirts of the wheel. With the protractor they can measure how many spokes or how many veins they're going to divide the wheel. You know, they decide that, you know, it could be 16, could be 8, could be 24, whatever. You just have to divide 360 degrees into the number of divisions and use the protractor to measure that. And then whoever's gonna cut puts the gloves on and cuts the drawing out of here, and then use the pliers to twist the metal sheet to produce things like present in this wheel. Okay. So now the computer is still loading. Again, you gotta be very patient because this is an old computer, it takes a while, but I'm gonna show you how to open up the proper document to enter the data. Meanwhile, I'm just gonna show you here again, we're gonna be 4 people per table, except for the very last one, we're gonna have 5. One person goes and measures the diameter, and then the other people work together to design the water wheel and draw it and cut it, and then we're going to test it in here. And the specifics of the test I'm going to have to give them to you some of the time because we haven't finished up putting it together. But once we have calculated the efficiency of the water wheel, we're going to write it up in this board. Okay. In the board I have a diagram of water power generation that you can talk to students about, indicating that, you know, the water power uses potential energy of the water height to be released in a penstock, which moves the turbine, which moves the electric generator. The electric generator inside the powerhouse produces electricity that is sent to the distribution system back into the cities and industries. And the water that gets used goes into the river downstream, and that's the basic principle of a hydroelectric power system. Now we're going to have 4 groups, and so I have this collection of data for group number 1. This is going to be like Tuesday morning, Tuesday afternoon, Wednesday morning, Wednesday afternoon. Each of the 6 groups is going to choose a name. They're going to write down the name and the efficiency that results from running the computer. And the computer is ready here to open the documents. What we have to go is go to My Documents and double click on it. That's the My Documents icon. And then as soon as you get that sand clock, then something's happening there. Now, again, this is gonna take a while. You can see that the sand clock comes and goes, and so we're just gonna wait until the computer is ready to be activated. I'm just going to stop the video here and start a new one when we get to the point.